A yacht is sailing from Port A in the northeast direction with a speed of 15 kilometers per hour for 30 minutes. Then it turns to the southeast direction and sails with a speed of 18 kilometers per hour for 20 minutes. The yacht is now set to return to Port A. What is its bearing now from Port A? What must the speed of the yacht be if it needs to reach Port A in 40 minutes? These are examples of problems involving bearing. This kind of problem may occur not just when we are on a ship. They may occur when we are on land also. For example, when we are trying to find our way back after going for jungle trekking. So, how do we solve these problems? That is what we are going to learn about today. We are going to learn how to solve problems involving bearing. Before we see some examples, let's recall what we have learned in our previous lessons about bearing. First, we learned how to state the compass angle of any compass direction, where the angle is always measured in degrees in a clockwise direction from the north. Second, we learned how to draw a diagram to show the direction of point B relative to point A, given the bearing of point B from point A. Here, the bearing is also measured in degrees in a clockwise direction from the north at point A. And third, we learned how to state the bearing of point A from point B based on given information. In today's lesson, we are going to apply the skills that we have acquired through these lessons and other lessons from the topic of trigonometry to solve problems involving bearing. Example 1. In a treasure hunt game, Murat's group was asked to walk a distance of 46.5 meters at a bearing of 060 degrees from the starting point. The treasure was actually 77.5 meters away at a bearing of 120 degrees from that starting point. When Murat's group reached the appointed location, another instruction was given to them about how far they had to walk and in which direction from their current position. Find how far the group has to go and the bearing of the treasure from the appointed location, given that the bearing of the appointed location from the treasure is 330 degrees. Solution. First, let's label the starting point as P. Draw a compass direction pointing north at P. The first instruction reads, walk a distance of 46.5 meters at a bearing of 060 degrees from the starting point. So, estimate an angle of 60 degrees from the north at P. Then, draw a line from P. At the end of this line, we label the point as A for the appointed location. Write the length of this line, which is 46.5 meters. The second information given is that the position of the treasure is 77.5 meters away, at a bearing of 120 degrees from the starting point. So, estimate an angle of 120 degrees from the north at P. Then, draw a second line for P from this angle. This line should be longer than the first line as the distance is much further. At the end of this line, we label the point as T for the treasure. Write the length of this line, which is 77.5 meters. The third information says that the bearing of the appointed location from the treasure is 330 degrees. So, we draw a compass direction at T, connect A and T with a straight line and draw the angle 330 degrees from the north at T. The second instruction for Murat's group will be the bearing and the distance of the treasure from A. So, we need to draw a compass direction at A also. Now, look at this angle. What is the size of this angle? Yes, it is 360 degrees minus 330 degrees, which is 30 degrees. The two arrows here are parallel. So, these two angles are equal because they are alternate angles. Hence, the angle here is also 30 degrees. These two arrows are also parallel. So these two angles are equal. Thus, the angle here is 60 degrees. 60 plus 30 is equal to 90 degrees. Hence, triangle PAT is actually a right-angled triangle. By using the Pythagoras' theorem, we can find the distance between A and T. AT is equal to the square root of 77.5 meters squared minus 46.5 meters squared, which is equal to 62 meters. Now, what about the bearing of T from A? Let's first identify the angle for this bearing. The angle must be measured from the north at A until the line joining A and T. The size of this angle is 180 degrees minus 30 degrees, which is 150 degrees. Thus, the second instruction for Murat's group is walk a distance of 62 meters at a bearing of 150 degrees from this position. Example 2. Here, we have a diagram on a horizontal plane. We need to find the bearing of A from B and the shortest distance from B to the midpoint of AC, given that the distance between B and C is 200 kilometers. Solution. To find the bearing of A from B, we need to first draw the compass direction pointing north at B. This is the angle for the bearing of A from B. This angle we know is 180 degrees. What about this angle? These two angles are alternate angles, so they are equal in size. Hence, this angle is 40 degrees. Now, AB and BC is of equal length, and since they are between two parallel lines, then these two angles have the same value, which is 40 degrees. 180 degrees plus 40 degrees equals 220 degrees. Thus, the bearing of A from B is 220 degrees. Example 3. A lorry travels southeast from K for 90 kilometers. Then it turns and moves southwest for another 80 kilometers and stops at M. Find the bearing of M from K. Solution. First, we draw a diagram to represent the journey. Starting from point K, we draw a compass direction pointing north. Then, we draw the line for the first journey, which is 90 kilometers in southeast direction. Next, we draw the second line for the second journey, which is 80 kilometers in southwest direction, and mark the end of the line as M. As we want to find the bearing of M from K, we need to draw a line from K to M. This is the angle that we are looking for. We already know the size of this angle, which is 135 degrees. Now, we need to find the size of this angle, say theta. The triangle that we have drawn is a right-angled triangle. So, by using the tangent function, we find the angle to be 41.6 degrees. 135 plus 41.6 equals 176.6. Thus, the bearing of M from K is 176.6 degrees. Example 4. Eunchik Khair drives his car westward from his house with a speed of 60 kilometers per hour. His home is located 10 kilometers south of Eunchik Amir's house. Half an hour after Eunchik Khair starts his journey, Eunchik Amir drives his car northward from his house with a speed of 70 kilometers per hour. Find A, the distance between the two cars 1 hour after Eunchik Khair starts off, and B, the bearing of Eunchik Khair's car from Eunchik Amir's car after that 1 hour. Solution. Given that Eunchik Khair's house is located 10 kilometers south of Eunchik Amir's house. So, if this is the point for Eunchik Amir's house, then straight down below this point is Eunchik Khair's house. The distance between the 2 points is 10 kilometers. Eunchik Khair starts his journey first towards west. His speed is 60 kilometers per hour. After 1 hour, he has traveled a distance of 60 kilometers. Now, half an hour after Eunchik Khair starts off, Eunchik Amir drives from his house towards north. His speed is 70 kilometers per hour. So, after the next half an hour, the distance from his house is 35 kilometers. So, the distance between the two cars is the length of this line. Notice that the shape that we have drawn is a right-angled triangle. Hence, we can use Pythagoras' theorem to find this length. The square root of 60 kilometers squared plus 45 kilometers squared is equal to 75 kilometers. Thus, the distance between the two cars 1 hour after Eunchik Khair starts off is 75 kilometers. After that 1 hour, this is the bearing of Eunchik Khair's car from Eunchik Amir's car. To find this bearing, we need to find the size of this angle first. Let the angle be theta. We can use any of the trigonometric function to find the value of theta, since we already know the length of each side of the triangle. Let's use the cosine function. So, cosine theta is equal to 45 over 75, which is equal to 0.6. Hence, theta is equal to 53.1 degrees. 180 degrees plus 53.1 degrees is equal to 233.1 degrees. Thus, the bearing of Eunchik Khair's car from Eunchik Amir's car after that 1 hour is 233.1 degrees. In today's lesson, we learned about how to solve problems involving bearing. Following Polya's method of solving problems, first, analyze and understand the problem. If it is not already given, draw a diagram that represents the given problem. Determine where north is in the diagram so the direction of movement of the object can be identified. If the question asked for the bearing of a point from another point, then draw a compass direction pointing north from the latter point. Second, plan a strategy and decide if the calculations involve the Pythagoras' theorem, or the trigonometric functions, or both. It may also involve some characteristics of angles between two parallel lines. Third, execute the plan and find the solution. Finally, check the solutions to make sure that they are correct.